Hello everyone, my name is Rakshita. I am from Sri Venkateshwara College of Engineering from the Department of Electronics and Communication Engineering, third year. Today I am going to discuss about the subject called microwave and antenna. So in this subject I am going to discuss about the topic called microstrip lines and derive the characteristics impedance for the microstrip line. So now let's see what is microstrip lines. Microstrip is a type of electrical transmission line which can be fabricated with any technology where a conductor is separated from a ground plane by a dielectric layer known as substrate. Microstrip lines are used to convey microwave frequency signals. Typical realization technologies are printed circuit board, alumina coated with a dielectric layer, or sometimes silicon or some other similar technologies. Microwave components such as antennas, couplers, filters, power dividers, etc. can be formed from microstrip with the entire device existing as the pattern of metallization on the substrate. Microstrip is thus much less expensive than traditional waveguide technology, as well as being far lighter and more compact. The major disadvantage of microstrip compared with waveguide are the generally lower power handling capacity and higher losses. So this is the diagram of the microstrip line. These are the conductor strip, these are the dielectric substrate, these are the ground plate, and this is the width of the conductor strip, and this is the height, and this is the thickness of the conductor strip. Now let's derive an expression for the characteristic impedance Z0 for microstrip line. Microstrip lines are used extensively to interconnect high-speed logic circuits in digital computers because they can be fabricated by automated technologies and they provide the required uniform signal path. This figure shows cross-section of microstrip line and a wire over ground line for purpose of comparison. The figure A is microstrip line and the figure B is a wire over ground line. Microstrip line is a function of the strip line width, the strip line thickness, the distance between the line and the ground plane, and the homogeneous dielectric constant of the board material. Several different methods for determining the characteristic impedance of a microstrip line have been developed. The field equation method was employed by several authors for calculating an accurate value for the characteristic impedance. However, it requires the use of a large digital computer and is extremely complicated. Another method is to derive the characteristic impedance equation of a microstrip line for a well-known equation and make some changes. This method is called comparative or an indirect method. The well-known equation of characteristic impedance of a wire over ground transmission line is given by Z0 is equal to 60 by root of epsilon naught R log of 4h by d, where h is much greater than d, where epsilon naught R dielectric constant of the ambient medium, h is the height from the center of the wire to the ground plane, d is diameter of the wire. If the effective or equivalent values of the relative dielectric constant epsilon r of the ambient medium and the diameter d of the wire can be determined for the microstrip line, the characteristic impedance of the microstrip line can be calculated. Effective dielectric constant epsilon Re. For a homogeneous dielectric medium, the propagation delay time per unit length is Td is equal to root of mu into epsilon. where mu is the permeability of the medium and epsilon is the permittivity of the medium. In the free space, the propagation delay time is TdF is equal to root of mu naught into epsilon naught, which is equal to 3.33 nanosecond per meter. In transmission lines used for interconnection, the relative permeability is 1. Consequently, the propagation delay time for a line is non-magnetic medium is Td is equal to 1.106 into root of epsilon E. The effective relative dielectric constant for a microstrip line can be related to the relative dielectric constant of the board material. The empirical equation is expressed as epsilon Re is equal to 0.475 into epsilon R plus 0.67, where epsilon R is the relative dielectric constant of the board material and epsilon Re is the effective relative dielectric constant for a microstrip line. This is the diagram for the effective dielectric constant as a function of relative dielectric constant for a microstrip line. The x-axis is relative dielectric constant Er, the y-axis is dielectric constant epsilon R. Transformation of a rectangular conductor into an equivalent circular conductor. The cross section of a microstrip line is rectangular, so the rectangular conductor must be transformed into an equivalent circular conductor. Springfield discovered an empirical equation for the transformation. His equation is D is equal to 0.67 into W into 0.8 plus T by W, where D is the diameter of the wire over ground, W is the width of the microstrip line, T is the thickness of the microstrip line. The limitation of the ratio of thickness to width is between 0.1 to 0.8. So the characteristic impedance equation is Z0 is equal to 87 by root of epsilon R plus 1.41 into ln of 5.98 h divided by 0.8 W plus T. So this is the figure that shows the relationship between a round conductor and a rectangular conductor far from its ground plane. So Z0 is given by h by W into root of mu by epsilon, which is equal to 377 by root of epsilon R into h by W. So thank you for watching my video. Please do like the video, share and subscribe to my channel.